Hello, welcome. Let's try to solve another Leetcode problem. Leetcode 30, substring with concatenation of all words. So let's just try to understand the problem. So for example, we are giving this string S, it has something like a bar full, yeah, and we are also giving words. And inside of the words array, it's gonna be a number of words. So a number of words. So for example, this is full and this is bar. And all the strings of words are of the same length. So this is very important. Otherwise, we cannot solve the problem so easily. So all the words are of the same length. So this means this full and this bar, the lengths are equal. So basically this means we can take the word one by one because the lengths are equal. So for example, from the beginning we can take something like bar, something like full, something like the, yeah. So it is possible. Or we can start in from ARF, yeah. Or we can start from RFO. So it is also possible, yeah. But after that, do we need to start from FOO4 again? We don't need. We just need to check a word because all the words are equal inside of the words array. And what we're gonna return? We just need to return the first index. So for example, from B, this is gonna be the first index 0, and this bar full, it's gonna have two words. And inside of the words array, it is just that two words. So we're gonna return this index as 0, and then we're gonna starting from here, this full bar. So this is gonna be index 9. We just need to return the index 9 because starting from a full and bar. This is a substring, and the substring will be concatenating of two words inside of the words array. Yeah. And similarly, we can check the second example. So inside of the second example, it is not possible. So we're gonna return an empty array. And for the third example, we're gonna return like index 6. For example, from 6, it is a full bar. It is the index 6. It means it is okay, and then bar the full, it is also okay, and the full and bar, it is also okay. It is just a combination of all those words inside of the words array. Yeah, and we can see that from here, here, and here, it seems that this problem can be solved by sliding window. If we just use the two counters to compare with them, because yeah, we are just have a problem of time limit exceeded issues because they just introduce more testing cases. It means it is not possible to solve it by using brute force. We have to use a better way to solve it. So this is the sliding window. So the idea of sliding window is that, so from the beginning, how many positions of the word we're gonna check. So for example, the length of the words. For each of the word, the length of the word is 3. So this means we just need to check 3 index. It's gonna combine of all the cases. So what is the length of the word? So the time complexity gonna become the length of the words and how many words. It's gonna be 30 times 5,000. That is why a sliding window works. Yeah. So the sliding window idea is we're gonna check the first index. For example, this is the index 0. So we're gonna start from this index 0, and we're gonna have a counter array. So we're gonna have a counter. So the counter of the words counter. It means inside of the counter, we have a bar. How many bars? We have 1. And how many full? We also have 1. And how many is? It also has 1. So this is from the beginning, and we can calculate it easily. We just need to use a counter to count how many words. And this is the counter, and this is the frequency. And then we're gonna start the sliding window. So for example, this is a bar. We know that in another counter, this is maybe I'm gonna call it the current counter. So this is gonna be the current counter. Yeah. So inside of the current counter, how many bar? From here, we're gonna count this 1 bar, and then we're gonna have a full. How many full? We have 1 full. And how many full? Here we have 2 fulls. So this means that this is not possible because inside our current counter, for this full word, it has more word of full in my current counter than the counter itself. So this frequency is 2, it means it is not possible. So if it is not possible, we're gonna update the left border. So the left border. So because this is full, it means it is not possible. So the left border gonna starting from here, from this bar, and the R border will also be starting from this bar, and we're gonna code it again. Yeah, and we're gonna clear the counter array. We're gonna clear the counter. So for here, starting from here, this is a bar, we're gonna code it as 1, and this is we're gonna from here we're gonna code it as 1, and this is full, we're gonna code it as 1. Now what happens is that this is the R border, this is the left border, so the right border minus the left border gonna equal to the number of the words times the word length, gonna equal to 9 for this example. If it is equal to 9, this means we've already found the answer. We just needed to put the left border inside our final array. So in this way, we're gonna yeah, I'm sorry, I did something wrong. Actually, it should be starting from this full and not bar. It's gonna be starting from this full. This is gonna be the L border. This is gonna be the R border. So in this way, we're gonna put the index 6, 9, and 12, yeah, inside the array, and this is gonna be our final result. Yeah. So this is bar, this is full, and this is full because there are two full. So we need to update the left border. So this L gonna be updated to here, and this L gonna be updated to here, because up to here this full gonna become a 1. Yeah. So I did something wrong about my explanation, but the basic idea is just the sliding window. We're gonna use the sliding window to solve it. Yeah. But for the sliding window, normally we're gonna shift the left border and right border by 1 position at each time. But according to this problem, length of the word is equal. So this means we're gonna, if the length is 3, we're gonna update 3 positions for the right border, and similarly for the left border, it's gonna update with the 3 positions, the length of the word positions. Yeah. I think if we understand that we're gonna use the sliding window to solve the problem, basically we should understand how we're gonna code it. Yeah. So I'm gonna prepare the word length. It's gonna be a lot of variables and words number. So the word length is gonna be I'm gonna choose the first word and check the length. So it's gonna be the word length. So we should know the word length and how many words I'm gonna use the length of the words array. And I'm gonna use total length. So this means if we find one of the result, what's going to be the total length? It's going to be this word length times the word number. And I will prepare a count. This count is for counting the words. So I'm going to use a counter to count the words, and to the same time I'm going to prepare a final result, because finally I'm going to return this result. Yeah, so inside of the result array, it's gonna be several indices. Now I'm gonna check it. So for I in range word length, and I'm gonna prepare left and right border gonna equal to I, and I'm gonna prepare a current count. So the current count gonna be empty counter. Now I'm gonna use a while loop. So this is actually the sliding window part. Yeah. So before the sliding window, we need to do some preparations. We need to prepare an empty counter, and we need to prepare the left and the right border. Yeah. After preparation, we're gonna start with the sliding window solution. So while the right border plus the word length, and equal to the length of the string. So this is very important. It must be equal, because this is not shifted by 1 and 1. It is shifted by the length of the word 3. If we do not use equal, we might miss the last word. So this is not good. So we have to use equal. So we're gonna get a word. It's gonna be the S string of R to R plus the length of the word. Yeah. Yeah, but before we use the sliding window, we need to make sure the word is inside the counter, is inside the count. Otherwise, we cannot use the sliding window. So let's just take out this word. So we're gonna take out this word because we need to check if it is inside, and then we're gonna use the sliding window. Otherwise, if it is not inside, we're gonna stop it immediately. We don't need to run the sliding window part. So we're gonna prepare this word, and we need to have it check. So if the word is inside the count, so we're gonna run the sliding window. So else, if the word is not inside, we're gonna update the counter. So we're gonna clear it, and the left border gonna equal to L gonna equal to R. Yeah. So now what happens is if the word is inside the count, so for the while loop, if the word is inside, and also this is less than or equal to the length of the string, we're gonna update the counter. So the current counter gonna plus equal to 1, and we're gonna update the right pointer. So R gonna plus equal to the length of the word. Yeah, but what if the count counter with this word is more than the counter inside the count, for this word? So definitely we need to set the left pointer for the sliding window. Yeah, so if it is more than that, we're gonna prepare a previous word. So the previous word is gonna be the s of L to L plus the word length. So the current count with this previous word gonna minus equal to 1. Yeah, but this should also be a while loop. Yeah, because for the right border and the left border, we should always use a while loop to check. Yeah. So for the left border, while this is more than that, we're gonna find the previous word. It's gonna be from the left border to left border plus the word length, and we're gonna update the current counter. And the left border gonna be updated to plus the word length. So now what are we gonna do? After the while loop, we need to check if R minus L equal to the total length. It means we've already found one of the possible cases. We're gonna just append the left border. Yeah, I know it is a lot of coding. Actually, it is not so easy to do, but basically we need to understand that we're gonna use a sliding window to solve it. So this is just preparation of the sliding windows. We're gonna prepare a count counter, and we're gonna prepare the left and the right border, and we're gonna prepare the word. So the word is gonna be the first one. So this is gonna be the first word. If it is inside, we're gonna run the sliding window. Yeah, I'm not sure if it is okay. It seems so yeah, I'm not sure. Let me just run it. Yeah, maybe yeah, it will be time limit exceeded. That means my checking is not okay. Yeah, I need to yeah, let me just take out this one, and I'm gonna starting from checking the R pointer first. Yeah, so I'm gonna checking from here. So while the R pointer plus the length of the word is less than or equal to the string S, I'm gonna find a word. Yeah, so this is my word, and I'm gonna update the current coder, and I'm gonna update the R pointer. Yeah, so while this is working, and then I'm gonna check if this word is inside the code. If it is inside, yeah, so I'm gonna check it from here. Yeah, I have the right pointer, and I have the length of the word. If it is meet the condition length of the string, so I will update my word. So this will be my first word. If it is inside the code, I will do something. Otherwise, I will just clear it. So for example, first one, it is a bar. It is inside the counter. Yeah. But if it is not inside, I'm gonna clear it. So if this is inside, I'm gonna update the current coder, and I'm gonna update the right pointer as well. Yeah, but I don't need to update the right pointer from here. I need to update it from here, because I need to check word one by one until I find where it is. Yeah. So I find a word and I update the right pointer, and then I'm gonna check this word. If it is inside the code, I'm gonna update the current code. If it is more than the counter for this word, I'm gonna slide from the left side for the sliding window. Yeah. After sliding, I still need to check if it meets the condition. If it meets the condition, I'm gonna put the index inside the result array. Yeah. Now let me just run it. Yeah. Now it works. Yeah, it is a lot of logic here. We have to be really clear with what we are doing for the sliding window. So before running the sliding window, we have to do some preparations, basically left and right pointer and a counter, a current counter. And then we're gonna check from the right side. Yeah, we're gonna find the word and we're gonna update it. If it is inside of the code, first of all, we're gonna update the current code. And then we're gonna use a while loop to check if it is the frequency of the current code for this word is more than the counter of this word. If it is more than, we're gonna slide the left side of the sliding window. After sliding, we still need to check if there is a possible result. So if we find a word that is not inside the counter, we're gonna clear the counter and update the left pointer. Yeah. Now let me just run it to check if it works. As you can see, it works and it passed for all testing cases. It is pretty fast because the time complexity is just the sliding window. Yeah, it is just 30 times 5,000. So for this for loop, this is the length of the word. It is just 30. And for here, while and while, we are using two whiles, but as this is a sliding window, for each updating of pointer, actually it is the length of the word. It means basically we are checking how many words. It is 5,000. There are going to be 5,000 words inside of the words array. So the time complexity is going to be 5,000 times 30. That is why it's fast. I think that's all about it. Thanks for watching. See you next time.